Analyzing function notation, solving equations, and inequalities. Taking function notation to another level. For success today, you need to read and interpret the notation, solve equations for x, solve inequalities for x, and sketch solutions on number lines. Given the following functions, we're going to find values, in this case, for example 1, where f of x equals g of x. So again, we're finding all values of values of x where f of x equals g of x. So f of x is 4x minus 5, and I want to see where it equals g of x. And g of x is negative x plus 3. In order to do that, I set them equal. I'm just going to solve for x. And my x is on the same side. So 5x minus 5 equals 3. Get the numbers to the other side. So 5x equals 8. And to solve for x, I divide by 5. So my answer is x equals 8 over 5. So where x is 8/5, those two functions are equal. Now we want to find all values of x where the function f is greater than j. And when we're done, we're going to use a number line to show the solution set. Similar to last time, I have f, which is 4x minus 5, and I want to see where it is greater than j of x. And j of x is 5 times the difference of x and 2. And I'm going to do the same thing here. I want to solve for x. Well, on the left side, I still have 4x minus 5. It's greater than. Now I distribute 5x minus 10. Okay. I'm going to move the smaller amount of x's here. And you can solve however you wish. So negative 5 is greater than x minus 10. And I can add 10 to get x by itself. 5 is greater than x. Well, remember back to Algebra 1, the notation, we want x to be on the left. So when I move it, I just flip that sign. So x is less than 5. And I also want to use a number line to show the solution set. So I've got my number line. Always try to include 0 here. Doesn't matter what your increments are as long as you're labeling those increments. So I'm just going to go 5 and 10. Negative 5, negative 10. Okay, x is strictly less than, so my circle is open, and less than goes to the left. So if you want to shade your function, your graph to the left, that will be the set of values, or the solution set. Example 3, find all the values of x where 5 is less than g of x, which is less than or equal to 15, where g of x is negative x plus 3. Okay. Now when I'm solving for x here, I just need to make sure I do the same operation to all 3 parts of my inequality. So I'm getting x by itself by subtracting 3 everywhere. And I get 12. I still have a negative sign, so I'm going to divide that guy out. Remember, when I divide by a negative, I switch the sign. Switch my inequality symbol. Okay. And we always want the smallest numbers to be to the left, so I'm just going to flip everything back. Less than negative 2. So that's my inequality. Again, the solving piece, that should be a review from Algebra 1. We just have a little bit of new notation here. Okay, we should all be able to solve for that inequality. Now we can go to the number line. Put 0 here. I'm going to go by 2's. Negative 12. There's negative 2. So it can be equal to 12, but cannot be equal to 2. And I shade. Example 4. Find all values of x where h of x is greater than 3, where h of x is 3x plus 4 all over 2, which is greater than 3. Again, I'm replacing h with its function rule and solving for x. Well, to undo a quotient, I'm going to multiply both sides by 2 times 2. Now that's gone. I've got 3x plus 4 is greater than or equal to 6. Solving for x, I've got 3x is greater than or equal to 2. So x is greater than or equal to 2/3. Okay, I know it's a fraction, but we can still find its approximation on a number line. 0, 1, 2, negative 1, negative 2. Okay, 2/3. If you think about 2/3, okay, it's bigger than 0, but it's going to be less than 1. So it's somewhere between 0 and 1. Okay, more towards 1. Okay, and it's everything greater than or equal to 2/3. I'm going to shade to the right. And our last one. This one's tough, but we still should be able to do it. So we want to find all the values of x where f of g of x plus j of x minus h of 2 is less than or equal to 20. Being organized is going to be another key to success here. So I have f of g of x. Again, I'm putting g into f. So f of g of x would be f of negative x plus 3, because that's the function rule for g, plus j of x, which is 5 times the difference of x and 2, okay, minus h of 2. I want to do a little work for h of 2. I'm plugging in 2, okay, plugging in 2 into my function h. So where I see an x, I'm putting a 2. Okay, so 3 times 2 plus 4 all over 2 is going to be h of 2. And then all of that is less than or equal to 20. Okay, so I had f of g of x plus j of x minus h of 2. Now I can continue to simplify. I'm putting negative x plus 3 into f for x. Okay, so f is 4x minus 5, where I see an x. I'm going to plug in negative x plus 3, and then minus 5 to finish out f. Okay, I can take some more simplifying steps for j. So I'm going to distribute next. So plus 5x minus 10. And now I'm going to simplify h of 2. Well, 3 times 2 is 6, plus 4. So the numerator of this fraction is going to be 10 over 2 gives me 5. And that's all less than or equal to 20. Distribute the 4. Negative 4x plus 12, and I'm going to combine the rest of my like terms on the left side of the inequality. Okay. So I still had 5 x's. I'm going to combine my constants here. That'd be a negative 20, and then that is all less than or equal to 20. My next step, continue to combine like terms. So I had negative 4 x's. I'm adding 5, so I've got x, and then positive 12 minus 20 gives me negative 8, and that's less than or equal to 20. And to solve for x, x is less than or equal to 28. And I can show that solution set on a number line. Okay. 14 is a factor of 28, so I can go by factors of 14. Okay. It can equal 28, and it's everything less than or equal. And there you have it.